Hello and welcome back everyone to another video on AWS Cloud and DevOps Solutions. My name is Dinesh from Consultech, and today we're going to do a quick walkthrough on how you can easily integrate AWS CodeCommit with Jenkins that is hosted on an AWS EKS cluster. As is the case with most of our videos, we will be talking through the design and setup of our solution as described in our company blog post. You can find the URL for the blog post listed in the description given below. Being a cloud and DevOps consultant myself, I know Jenkins is a very popular choice within many organizations as the go-to tool used for infrastructure or application CI/CD. Having said that though, from my experience when it comes to deploying Jenkins, most teams struggle with security and automation. The reason why I say this is because a lot of blogs and videos out on the internet go through a few things, where one is the process of creating Git HTTPS credentials in an IAM user, and another where you configure the Git client to use AWS CLI credentials helper in the server where Jenkins is being deployed on. Now, this is absolutely fine, and of course the process works. But the main problem comes when you have to think about automation and how you are going to manage those credentials in a secure manner. Since AWS CodeCommit and Jenkins, which in this case is deployed in an AWS EKS cluster, are both within the AWS ecosystem, you don't necessarily have to create any long-lived IAM user credentials. Instead, you can use temporary security credentials by using AWS's implementation of IAM role to Kubernetes service accounts bindings. This will be the main focus of this solution, which we are going to demonstrate. If you want to know more information about how you can associate IAM roles to Kubernetes service accounts, please check out the link as shown in the web page. Let's start by first going through the design overview. As per the high-level diagram, the solution uses a Helm chart to deploy Jenkins to an AWS EKS cluster. The orange square shows the boundary of the AWS EKS cluster with managed or self-managed worker nodes. And the blue square shows the boundary of the Kubernetes namespace in which the Jenkins deployment is done. Now, there are lots of resources or Kubernetes resources that gets created via the Helm chart, but we have only shown the Kubernetes resources that are relevant to the solution. Click on the link shown on the web page if you want to know more information about the Kubernetes resources that gets created by the Jenkins Helm chart. Coming back to the design, the default installation of the Jenkins Helm chart creates a Kubernetes stateful set, which then creates the Jenkins controller pod. The controller pod uses a specific Kubernetes service account to perform its tasks. Now, there are a bunch of plugins that also gets installed as per the default installation of Jenkins, one of them being the Kubernetes plugin. You can click on the link shown on the web page if you want to view more information about the Kubernetes plugin itself. This plugin can be used to create dynamic agent pods, which you can refer to run your Jenkins jobs. The solution also uses another Kubernetes service account used for these Jenkins agents pods, which is created by overriding Helm chart values file during installation. These two service accounts are then associated to IAM roles that has relevant permissions to grant access to the AWS CodeCommit repository. Now that we have a general understanding of the overall high-level design, let's jump onto the setup part where we go through four main components of the solution in a bit more detail. Just a thing to note is that the live demo which we will be showcasing next uses Terraform to provision all infrastructure. Therefore, we have provided Terraform code snippets in the setup section to highlight key property values of each resource. First component we are going to talk about is the AWS EKS cluster. Key things to highlight is first being the cluster version, It has to be 1.14 or later, which is a prerequisite for the Kubernetes plugin for Jenkins. Another one is the addition of the AWS EBS CSI driver cluster add-on, which is required to create Jenkins persistent volumes. Now, there are a bunch of security considerations mentioned in the blog post, such as disabling public access to the EKS cluster endpoint and ensuring that you create the AWS EKS control plane and worker nodes in private subnets, etc. However, please note this config provided below is only for demo purposes and should not be used for a production environment. Productionizing an EKS cluster is another task altogether. And if you'd like to know more in-depth information on tightening security controls for EKS, please click on the link shown on the web page. The next component is the AWS CodeCommit repository, where we store application sample code that will be accessed by the Jenkins pipeline job we create in step number 4. The third components are the AWS IAM roles. As described in the HLD, there are 2 Kubernetes service accounts created, one for the Jenkins controller and the other for Jenkins agent pods. Therefore, we are creating 2 corresponding IAM roles for the controller and agent pods. There are 2 properties to highlight. First one is the assume role policy configuration of the IAM role. Now, this should allow the Kubernetes service accounts to assume the corresponding role. The second one is to either have an AWS inline policy or a managed policy that grants access to the AWS CodeCommit repository created in step number 2. If you want to know more information about how you can use Kubernetes service accounts to assume AWS IAM roles, please click on the link shown on the web page and refer to the AWS documentation. The fourth and final component is the Helm chart that is used to deploy Jenkins to the AWS EKS cluster mentioned in step number 1. As shown in the Terraform code snippet, we pass a values file to the installation of the Helm chart. This values file will create an additional Kubernetes service account for the Jenkins agent pods as described in the HLD. You'll notice that we have provided annotation for both of these service accounts that will allow them to assume corresponding IAM roles mentioned in step number 3. We also install a list of plugins in addition to the default plugins provided by the Helm chart. The key plugin to highlight here is the CodeCommit URL helper, which is used to configure the Git client for usage with the AWS CLI tool without having to modify git config in the home directory. Finally, we have listed the pipeline configuration script where it uses a Jenkins file located in the CodeCommit repo mentioned in step number 2 to configure its pipeline job definition. You'll notice we have used the CodeCommit URL helper as an extension in the SCM Git definition. Putting everything together, we are now going to do a live demo where we showcase an automated solution of how you can integrate AWS CodeCommit with Jenkins hosted on AWS EKS. To do this, we are going to follow the instructions given in our sample code base, which is hosted in our company GitHub repository. Before we get started, let's quickly go through the README section in this repo. As we mentioned before, the Terraform code snippets that we've listed on the setup phase is taken directly from this code base. If we navigate to the Get Started page, you'll notice there are prerequisites listed, which is required for you to run this code base. The next is the setup of your environment, which is basically setting up your AWS CLI config and credentials of the target AWS account where you want to provision these resources. You can do this either of 2 ways. One is by creating an IAM user with API access keys. And the second is if you have configured AWS single sign-on, you can assume a role by configuring the corresponding config in your AWS CLI tool. Once you have this set up, we would recommend you to export the AWS profile so that any subsequent calls to the AWS API will target the corresponding AWS account. You can do this by verifying the account ID and caller information by issuing the AWS STS get caller identity API call. The next section talks about the tools and versions used to test this code base. So please ensure that you have the minimum versions listed in this documentation. Following on, we are going to talk about the setup phase, which basically refers to the Terraform S3 backend configuration used in the infrastructure Terraform module. Speaking of Terraform modules, we have two modules in this code base, and you can see them under the Terraform directory named Infra and Bootstrap. The Bootstrap module creates a DynamoDB table and S3 bucket, which is used as the backend for the infrastructure module. The infrastructure module is what basically creates all of the resources mentioned in the solution that we have described before. There are input variables listed in a Terraform var file, which you'll have to modify depending on your AWS account architecture. References for all of these variables are listed in the variables.tf file. Finally, we will be talking through the app section where you push all of the sample code that is listed in this code repository. You'll see the directory mentioned here. It's a simple Python code and the Jenkins file that describes the Jenkins job configuration. And once you push those code to the AWS CodeCommit repository that gets created in the infrastructure module, we will then follow the steps to navigate to the Jenkins admin console and run the Jenkins pipeline job, where it'll try to access the CodeCommit repository, download the sample code, and execute it. Okay, now let's go ahead and follow the instructions. Let's start off by navigating to the setup process and first cloning the Git repository. Let's copy the commands and paste it into a terminal. And once you have successfully cloned the repo, the step asks you to export the project root environment variable. And before I do that, I actually work with Docker containers where I install all the relevant binaries in Docker images for different projects, just so that I don't clutter my work laptop. Therefore, before exporting the project root environment variable, I will start up a Docker container and mount the current working directory to /project. If I do a list files there, you'll see the same directories and files are mounted. And once I'm happy with that, I can go ahead and export the project root environment variable. The next step is to add the configuration values in the backend.com file. So let's go ahead and do that. Now, there's no Vim installed in this Docker container, so I'm going to use another window. Let's cd into AWS cc Jenkins EKS and list the files. And the file is under Terraform backend.conf. I'm going to copy the name of the repo as a reference, which I'm going to use in the S3 bucket name. Let's call it consultech hyphen the name of the repo hyphen demo hyphen Terraform states. For the DynamoDB table, which is used for the Terraform locking mechanism, let's name it the same as the S3 bucket, demo hyphen Terraform hyphen state lock. The key, I usually prefix it with the AWS region. Southeast2 terraform.state, and the AWS region for the S3 bucket is going to be the same, which is AP Southeast2. Once you're happy, we can run and quit, and then go to the next process, which is executing the Terraform Bootstrap module. So let's navigate to the documentation of the Bootstrap module. First off, we have to set the input variables. So let's go ahead and copy those commands and go back to our terminal and paste it. You can do an echo on the variables that you just set, just to confirm that you've got the appropriate values. Now you'll notice these values are directly taken from the backend.conf that we just set previously. This is because the backend.conf will be used to initialize the backend in the infra module, which we will be running next. So echo S3 bucket name, and finally echo DynamoDB table name. Once we're happy, let's go into the Bootstrap module directory, copy the command and paste it. Once we're there, you can list the files. And first off, we need to initialize Terraform. Terraform init. Once Terraform has been successfully initialized, you can run the Terraform plan and check the output. However, with the interest of time for this demo, we're going to go ahead and straight away apply the Terraform config. Copy and paste it there. Now we have already configured our AWS CLI, the config to the target AWS account. We're using a demo account for this purpose. And once the Terraform has successfully finished applying the config, we will show you the S3 bucket that was just created by this module. There you go. There are 7 resources that were created. So if we go into our S3 console, you'll notice that I haven't refreshed the page before. So if I refresh it now, I should see the S3 bucket that we just created. The next step is to execute the Terraform infra module, where it will provision all required infrastructure to demonstrate AWS CodeCommit integration with Jenkins deployed on the EKS cluster. We're not going to modify the input variables because it's already set to the appropriate values. So let's go ahead and initialize Terraform and apply the configuration. First off, let's change directory. So copy the commands, go back into our terminal, paste it, and you can double check by listing the files. Next up is to initialize Terraform, and as I mentioned before, we are using the backend config which we configured in the setup process. Paste the command and wait till Terraform initializes the backend. Okay, Terraform has been successfully initialized, and now we can go ahead and apply the configuration. Just a thing to note that this configuration takes a lot of time to provision all the required infrastructure because it creates an EKS cluster and also the worker nodes. Therefore, we are going to skip to the end and show you the provisioned infrastructure just to save time. Okay, so the Terraform infra module has been successfully completed. And as you can see on the terminal, it has created 43 resources. And we have configured one output, which is the CodeCommit repo clone URL. And the module took approximately 15 minutes to complete. Before running through the next steps, let's go to the AWS console and check if all the resources has been successfully created. We are on the EKS console page, and as you can see, there's an EKS cluster named Consultech Demo. If we go into that and check on the add-ons, we have 4 add-ons created. The EBS CSI driver, CodeDNS, VPC CNI, and Kube proxy. And if we go on to the compute section, we have 3 managed nodes configured. And if you go into the resources section and click on stateful sets, you'll see that, let me refresh this. You can see that there's a Jenkins stateful set that's been created and the pod is running. The next component that we need to check is the CodeCommit repository, and there is a sample app repo created, but if you go into it, there's nothing in it. The next steps that we are going to follow will push the sample code in the Git repository to this CodeCommit repository. Next up are the IAM roles, and there is a cluster role for the EKS cluster and a worker role for the EKS managed nodes. The 2 things that we need to look at are the IAM roles, which are configured for the Kubernetes service accounts. And as you can see, this one is for the Jenkins controller pod, whereas this IAM role is for the Jenkins agent pods. We can now go ahead and follow the next steps. The final step is to push the sample code found in this code base to the AWS CodeCommit repository that we just created via the Terraform infra module, and then followed by logging on to the Jenkins admin console and running the pipeline to check if we can access the AWS CodeCommit repo by downloading it and executing the Python code. Let's go ahead and copy the first few commands, which is to clone the CodeCommit repository to the local workspace. Copy and paste it to our terminal. And as you can see, we are cloning the repository to the temp directory, and it's giving us a warning that we have cloned an empty repository, which is fine. Now we need to go ahead and copy the sample files from our code base to the temp directory that we just cloned to. If we do a list of the files, we can see the Jenkins file and the sample Python app. We're now going to modify the Jenkins file to insert the CodeCommit URL and the Jenkins agent Kubernetes service account name. Once you've done that, we're going to git add the changes and commit and push to the CodeCommit repository. Once you've done that, we can go back to the console and go back into the sample app repo and check if the 2 files are there. Once we're happy with that, let's go back to the third step, which is to log into the Jenkins admin console and run the pipeline job. First up is getting the kubeconfig from the EKS cluster. And so once you have that, we have to then get the Jenkins admin password. Let's copy that to our clipboard. And to log into the Jenkins console, since we don't have a VPN or we're not in a private network, we need to do a port forward to the Jenkins service. Let's copy the password again. Now that we're port forwarding to TCP 8080, we can open up a new tab and navigate to localhost 8080, and you'll see the Jenkins admin URL coming up. For the username, we specify admin, and the password is what we just copied, and sign in. As you can see, there is the pipeline job that's been configured, and if you go into that and check the configuration of that pipeline, you'll see that the CodeCommit repo URL has been entered, and we're using the CodeCommit URL helper to configure the Git credentials helper for the AWS CLI tool. And it's looking at the Jenkins file in the CodeCommit repo to configure the pipeline job definition. Let's go ahead and build it to see if we can access the CodeCommit repo. As you can see, updating the pipeline properties on first build. So it's asking us to rerun the pipeline with appropriate parameter values, which means that it has successfully cloned it. But let's just go ahead and rebuild it with parameters. Now you can see there are parameters that are configured via the Jenkins file, and we can click again to build and look on the console output. Now you can see there's been a dynamic agent pod that's been created via the Kubernetes plugin. There you go, the agent has been provisioned. And now it's trying to clone the Git repo. And it has successfully read our last commit message and has run the Python code which says, congratulations, you have successfully cloned AWS CodeCommit repository using IAM role to Kubernetes service account bindings. That concludes our live demo in which we have managed to show how you can successfully integrate AWS CodeCommit with Jenkins hosted on EKS without having to create or manage long-lived AWS access credentials. Hopefully, this video has been somewhat beneficial for you, and if you did find it useful, please give this video a thumbs up. Thank you for watching.